So today we are going to focus on uniformly accelerated motion. So what is uniformly accelerated motion? It is the motion of an object where the acceleration is constant. So the keyword there is constant. It does not change. Okay? In other words, the acceleration remains uniform. The acceleration is equal to a number, and that number does not change as a function of time. So what are the examples of uniformly accelerated motion? For example, we have here a vehicle moving towards east with an initial velocity of 0 meter per second. So starting from at rest. And then its final velocity after 3 seconds is 30 meters per second. So as you can see from our interval, after 1 second, the velocity is 10 meters per second. After 2 seconds, the velocity is 20 meters per second. And after 3 seconds, the velocity is 30 meters per second. So what can you observe regarding the pattern of the increase of the velocity?
It adds 10 meters per second.
It adds 10 meters per second in every second. So every second, the velocity increases by 10 meters per second. So let's try to compute the acceleration from 0 second to 1 second. And then compare that to 1 second to 2 seconds, then 3 seconds. How can we compute for the acceleration at this point?
Velocity over time, sir.
Velocity all over time. That's acceleration is equal to
Time.
velocity all over time, or change in velocity all over time. Diba? So,
Change in time.
and change in time. That's correct. So we can expand that into A is equal to VF minus VI all over TF minus TI. VF stands for final velocity, VI for initial velocity, TF for final time, and T for initial time. So we just substitute the given. VF is, what is VF in our first case? From 0 to 1 second, 10 meters per
10
second.
meters per second, sir.
Minus VI is 0 meter per second, minus TF is 1 second minus 0 second. So that is equal to 10 meters per second squared. We're going to compute for the acceleration from 1 second to 2 seconds. So the same formula, A is equal to VF is
20 meters per
20
second.
meters per second minus our initial velocity is 10 meters per second minus final time is 2 seconds minus 1 second. A is equal to 20 minus 10, that's 10 meters per second divided by 1 second. A is equal to 10 meters per squared second. So the same acceleration. From 0 to 1, 10 meters per second squared. From 1 to 2, 10 meters per second squared. Nakita natin na uniform yung kanyang acceleration. Constant acceleration. So that is uniformly accelerated motion. This one, this example. Another one is this case. Batang babae, nag-drop ng bola without initial velocity. The ball will accelerate at a rate of, from our diagram here, 10 meters per second squared. That means every second, the velocity increases by 10 meters per second. So after 5 seconds, its velocity becomes 50 meters per second. For our first example, this is horizontal motion. And for this one, this is vertical. Specifically, we have free, tinatawag natin na free fall. Now let's proceed with the equations for uniformly accelerated motion. It's very important that we have these equations for us to quantify the motion. So we already presented the following formula. For velocity, we have v is equal to displacement all over time. And in our discussion for today, we are going to remove the half arrow so that we can clearly write the formula. Automatic, when you see the v and d without the half arrow, those are velocity and displacement. If we try to compute for the other quantities, halimbawa, given si velocity at hanapin natin si d, kasi given pa ang t. So we can rearrange the formula to come up with this formula. So d is equal to v times t. We can compute for time given displacement and velocity. Another formula we presented in our previous discussions is a is equal to vf minus vi all over t. This is the same with the change in velocity all over change in time. Kapag ka-given naman ang acceleration, given si time, given ang initial velocity, we can rearrange the equation so that we can have a formula for final velocity. So all we have to do is to cross multiply. At is equal to vf minus vi. And finally, we can transpose vi punta dito. So that's plus vi. The final formula will be vf is equal to vi plus at. The blue ones are the derived formula from our original formula. So in terms of the units, for velocity, we're going to use the standard meters per second. Initial velocity, parehas then meters per second. Acceleration is meters per second squared, and time is seconds. So when we try to simplify that, cancel s and then s, meters per second plus meters per second, you can have a result of meters per second. So our formula is correct. Now, in case of given that are different from the desired quantity, for example, ang gusto nating malaman ay meters per second, ang nakalagay na given ay kilometers per hour, you have to convert kilometers per hour to meters per second. So, hindi mo pwedeng paghaluin yung hour at saka second sa iisang equation. Let's have a sample problem. You are driving down a street at 55 kilometers per hour. Suddenly, a child runs into the street. If it takes you 0.75 seconds to react and apply the brakes, how many meters will you have traveled before you begin to slow down? Ito yung starting point niya at 55 kilometers per hour. That's your direction. That's why it's positive. And then, suddenly, a child runs into the street. If it takes you 0.75 seconds to react, meaning na-delay yung pag-apply mo ng brakes, di ba? So, nag-travel ka muna within 0.75 seconds bago mo na-hit yung braking point. Since na-delay siya, dito lang yung start ng pag-brake mo, dito lang din yung start ng pag-decelerate mo. So, deceleration point. So, at this point, hanggang dyan sa point na yan, your velocity is still 55 kilometers per hour. How many meters will you have traveled before you begin to slow down? So, ito yon. Gaano kalayo ang na-travel mo? Can you suggest a way to solve for that?
Sir, convert po muna yung 55 kilometers per hour into meters per second.
Very good. Kasi, nakalagay sa formula, di ba? Meters and then seconds. So, we have to convert this one. So, 55 kilometers per hour times in
1,000.
1 kilometer, we have 1,000 meters times 1 hour, we have 3,600 seconds.
3,600 seconds.
So what will be the answer?
15, sir. 15 meter per second.
That's correct. We have 15 meters per second. Sir, alam nga iti jay. Ito po, 55 times 1,000, that's 55,000 divided by 11 times 3,600. So that is 15 point something. We round that to 15 meters per second. Two significant figures. That will be our initial velocity. After converting that to meters per second, what's next? Anong susunod?
Multiply.
Multiply. Saan natin i-multiply?
Multiply 15 meters per second to 0.75 second per second.
So if we're going
Seconds, sir.
if we're going to multiply 15 meters per second to 0.75 seconds, that is equal to 11 meters. So you suggest that that is the displacement. Tama? Okay. And that is correct. Paano tayo nakapunta doon? Remember, we are dealing with constant velocity. Constant velocity dito. Hindi siya nagbago. 55 kilometers per hour pa din. Kasi nagbago lang after the braking, which is after the 0.75 second period. So we can still apply the formula. Velocity is equal to displacement all over time. So displacement all over time. And like how we rearranged a while back the formula, we came up with displacement is equal to velocity times time. You can apply this formula as long as ito ha, the velocity here is constant. Hindi siya nagbabago. So using that formula, velocity times time, ito na, 15 meters per second times 0.75 second, the answer is 11 meters. So you traveled 11 meters bago ka naka-brake. Mapapansin ninyo, wala naman tayong nilagay na east, wala naman tayong nilagay na west. So makikita natin na yung sign niya ay positive, it's a positive number. Therefore, we are going to the east. What if acceleration is given and the duration of the acceleration is given, that's the time. Initial velocity is also given. So tatlo ang given, A, T, and this one is V sub I. Hinahanap ang displacement. Remember, yung kanina, constant velocity, walang acceleration, kaya pwede natin gamitin yung D is equal to V times T. But for this one, may acceleration. So therefore, velocity is changing. We can use this formula. D is equal to VI times T plus 1/2 AT squared. D is for displacement, VI for initial velocity, T for time, plus 1/2 AT squared. Let's apply that in our problem. An object with an initial velocity of 4.0 meter per second moves in a straight line under a constant acceleration. 3 seconds later, its velocity is 14 meters per second. Letter A. What was the acceleration of the object? Letter B. How far did the object travel during this time? So first step, we write the given quantities. Initial velocity is equal to 4.0 meters per second. Constant acceleration, 3 seconds. That's the time of the acceleration, 3.0 seconds. Its velocity is 14 meters per second after the 3.0 second mark. So that will be considered as our final velocity. In dealing with problems, word problems, class, you have to analyze the problem before listing down the quantities. If the quantity or if the number is mentioned later or in the last part of the problem, it does not mean that that's already the final value, ha? You have to analyze the problem. Yun ba ay initial talaga? Yun ba ay final? So in our problem, 14 meters per second is the final velocity. Our problem for letter A is acceleration, and for letter B, displacement. So letter A, for the acceleration. We can use the formula. Since VI is given, T is given, VF, A is equal to VF minus VI all over T. So A is equal to, VF is,
14 meters per second.
that's correct, 14 meters per second
Minus 4 meters
minus
per second.
4.0 meters per second all over time
3 seconds.
3.0 seconds. Acceleration is equal to
10
10
meters
meters per second
per
divided
second
by
over 3 seconds.
3.3 meters per second squared. Let's proceed with letter B. For letter B, our problem is the displacement. How far did the object travel during this time? Displacement is given by, based on our given data, meron tayong VI, T, VF, and acceleration. So yun yung na-mention kanina na formula, D is equal to VI times time plus 1/2 AT squared. So D is equal to VI is 4.0 meters per second times 3.0 seconds plus 1/2 or 0.5, pwedeng 0.5, palitan ninyo. Acceleration is 3.3 meters per second squared times 3.0 second squared. Simplify. So 4.0 times 3.0, that's 12 meters. Ang sagot dyan ay 14.85 or 15 meters. Kasi S squared, then S squared cancel, meters. So 12 plus 15, displacement is equal to 27 meters. Ayan. So let's proceed with another scenario. What if acceleration is given, initial velocity is also given, displacement is given, but there is no time, and we want to look for the final velocity. So anong gagamitin natin? Ito siya. Vf squared is equal to Vi squared plus 2AD. Let's apply that formula. A car is moving at 15 meters per second. As it approaches a red light, the driver starts to hit the brakes. As a result, the car starts to decelerate at a rate of 3.5 meters per second squared. What will be the velocity of the car after 15 meters? So, andito ka, travel ka, punta doon, 15 meters per second. Meron tayong red light dito. And so, magpepreno ka ngayon. Ang pagpreno mo ay 3.5 meters per second squared. Ang tinatanong, ano yung final velocity mo after 15 meters? Let's list down the given quantities. Our initial velocity, that is equal to 15 meters per second. As it approaches the red light, yan, deceleration of 3.5 meters per second squared. So we have a negative acceleration. Negative because it's opposite the direction of the, ito yung motion mo, yung acceleration mo ay pabalik para ma-stop, para mabawasan yung velocity. So that should be a negative acceleration of 3.5 meters per second squared. Ang tinatanong ngayon, what will be the velocity after 15 meters? So displacement is 15 meters, VF is unknown. So using this data, VI, A, and D, na-present na natin kanina yung formula, VF squared is equal to VI squared plus 2AD. The substitute the given quantities. VI is 15 meters per second, then squared plus 2. Acceleration of negative 3.5 meters per second squared times displacement is 15 meters. Vf squared is equal to, okay, 225 minus 105,
120.
that is equal to 120 meters squared per second squared. Yan na ba ang final velocity?
No, sir.
No. So anong
Cancel
gagawin
the
natin?
square.
How do we cancel the squared?
Square root.
We take the square root. Square root of 120,
10.95, sir.
that's 10.95 meters per second, or we have 11.0 meters per second. So we presented already the formula. Yung una ay V is equal to displacement all over time. For acceleration, that's Vf minus Vi all over t. Vf is equal to Vi plus 80. D is equal to Vit plus 1/2 80 squared. And Vf squared is equal to Vi squared plus 2AD. Now, yung mga diniscuss natin kanina ay horizontal. Pupunta naman tayo sa vertical motion. And one of the examples of vertical motion is free fall. What is free fall? It is the motion of an object where gravity is the only force acting upon it. And we have the following characteristics. Free falling objects do not encounter air resistance. So we're going to neglect wind, the effect of wind, and other external forces. Only the effect of gravitational force for free fall. Another one is all free falling objects on Earth accelerate downwards at a rate of 9.8 meters per second squared. So if we're going to draw that, if this is your positive going to the east, west is negative, upwards is upward from the origin of the motion, ito ay positive, downwards is negative. So therefore, our gravitational acceleration is equal to 9.8 meters per second squared downwards
9.8 meter per second squared.
or negative 9.8 meters per second squared. Ito ang gagamitin natin sa ating formula later on. Ayan, may negative siya indicating its direction. Ayan, so this G is equal to our A. Okay, acceleration due to gravity. So, for the applications in real life, ayan, skydiving is actually a free fall. Another one, ito, yung pinakita natin kanina, batang babae nag-drop ng bato or object. It will accelerate at a rate of 10 meters per second squared. That is actually the rounded value of 9.8 meters per second squared. For the others, yung ginagamit nila 10 meters per second squared. But in our discussion, we're going to use negative 9.8. Now, what are the equations for free fall? Yung pinakita natin kanina na mga equations ay para sa horizontal. Ang gagawin lang natin, i-apply natin, i-adapt natin yung mga yon papunta dito sa free fall para sa vertical. And of course, when we adapt the equations, we are going to make minor changes. Ano yung mga yon? Instead of A, originally A ito, papalitan natin ng G. Ibig sabihin, the acceleration here is due to gravity. That's constant. G is equal to negative 9.8 meters per second squared. Also this one, G and then G. Let's have the sample problems. An object was released from rest at a certain height from the ground. It took 5.0 seconds for the object to reach the ground. What was the velocity of the object as it reaches the ground, and from what height was it released? So I'm going to draw a diagram, an elevation or building or a cliff. An object is released here, yan, from rest. Ibig sabihin, ang kanyang initial velocity ay 0 meter per second. After 5 seconds, it reached the ground. The question is, letter A, what was the velocity of the object as it reaches the ground? We will assign that one as Vf. So given our initial velocity, our time, and of course, the gravitational acceleration, negative 9.8 meters per second squared, how can we determine the final velocity of the object as it reaches the ground? So Vf is equal to Vi plus
G
gt.
times.
So substitute natin, Vf is equal to Vi 0 meter per second plus negative 9.8 meters squared per second times time is 5.0 seconds. So 0, yan, omit. Negative 9.8 times 5.0. Negative
49.
49 meters per second. Kasi cancel, second squared, and then s. So this will be our final velocity. Why negative?
Because it moves
Kasi
downward.
free fall.
Because it is moving downwards and it is
Negative.
below the releasing point. Pag magkuhan tayo ng Cartesian plane dyan, ang ating point of origin ay yung starting point ng motion. We have here positive y, negative y sa baba. So kapag ka nasa baba ng point of origin yung motion, yung velocity niya ay downwards, negative, even the displacement will be negative. Our time, wala tayong negative and positive for time kasi wala naman siyang direction. Let's proceed with letter B. Now, what is the height? I'm going to draw the scenario. Time is equal to 5.0 seconds. G is equal to negative 9.8 meters per second squared. Vi is equal to 0 meter per second. Vf is equal to negative 49 meters per second. The question is, ano yung height? From what height was it released? Yung height na yan is related with the displacement from this point to that point. Meron tayong dalawang formula for displacement. The first one is, first option, d is equal to Vi t plus 1/2 gt squared. Option number 2, Vf squared is equal to Vi squared plus 2gd. So, aling formula ang pwede natin gamitin? 1 or 2?
Parehas sila, sir, pwede.
Yeah. Okay, tignan natin kung bakit parehas. Pag sa number 1, meron ba tayong Vi?
Yes, sir.
Yes. Meron ba
Yes,
tayong
sir.
time?
Yes, sir.
May
Yes,
time.
Yes.
May G,
Yes.
may time. Dito sa second naman,
Yes.
meron ba tayong Vi?
Meron po.
Okay.
Sir.
G and D.
Yes.
D, ito yung hanapin natin.
Okay.
Meron tayong VF.
D.
So, unahin natin na gamitin si number 1. We have D is equal to Vi t plus 1/2 gt squared. So, D is equal to Vi is 0 meter per second times time. That's 5.0 seconds plus 1/2 negative 9.8 meters per second squared times time is 5.0 second then squared. 0 times 5 is 0, so cancel. D is equal to 5 squared 25 times negative 9.8 times 1/2. Pakisimplify.
Negative 122
122.5
0.5 po.
meters.
meters per
Approximately, we have negative 120 meters. Ayan. Siyempre, height ang hinahanap. Displacement ito. So, therefore, your height does not have a direction. It's a scalar quantity. So,
Meter.
120 meters. Now, for number 2 equation, the number 2 equation is Vf squared is equal to Vi squared plus plus 2, that should be 2gd. Look for d. Okay? we can transpose this one. Vf squared minus Vi squared is equal to 2GD. Divide both sides by 2G. Divide 2G. Cancel. Therefore, D is equal to Vf squared minus Vi squared all over 2G. So, i-substitute natin. Punta natin dito. D is equal to 49 meters per second squared minus Vi
0 ms.
0 meter per second. Yan. So, cancel. All over 2, then negative 9.8 meters per second squared. Displacement is negative 49 squared divided by 2 times negative 9.8.
122.
Negative 122.5
.5.
or 120 meters. Our height will be 120 meters.
Sir,
Yes.
why not 123?
Why not 123? Bakit hindi 123? Kasi ang nakalagay ay 120 120?
122.5, sir.
122.5. Sir, bakit hindi nag 123? That's a good question. Remember significant figures. Go back to the problem. We only have 2 significant figures. That's why palagi yung sinasabi, balikan ninyo yung rules ng significant figures. Okay? So 1 and 2. So 2 SF dito. Our final answer should have 2 SF. Now, if we will have a final answer of 123, we have 3 SF for this one. So that is not a reliable way to express our final answer. But if we round that back to 120, so 120 meters, we only have 2 significant figures for this one. 1 and 2. 0 is not significant. Nagets?
Yes,
Yes,
sir.
sir.
So it's a matter of
Yes, sir.
how many significant figures is needed for the final answer. And you can determine that by looking at the given quantities from our problem. The maximum number of significant figures is 2 SF. So, your answer should have 2 SF also. And another one correction here, negative 49 squared is positive, right?
Yes, sir.
So, ang lalabas dito ay negative 120 kasi positive divided by negative. Okay, so parehas dito sa taas. But your height is a scalar quantity, so you only need the magnitude, that's 120 meters. Sample problem number 5. A ball is thrown upward and returns to the ground after 8 seconds. With what velocity was the ball thrown? How high did the ball go? So, ito yung ground. Meron tayong bola na ibato pataas. Saka bumalik ng after t is equal to 8.0 seconds. T sub t. Now, yung first question ay, with what velocity was the ball thrown? I-throw mo upwards, so anong velocity yan? So, that's Vi. How high did the ball go? Gaano kataas from the ground? So, you're looking for displacement. The only given here is time. Time taken by the ball to go upwards and downwards. For this problem, for this kind of situation, yung total time taken by the ball to go upwards and downwards can be divided into 2. Outcome will be 4.0 seconds. Kasi parehas ang time ng pagtaas, t upwards is equal to t downwards. Kung ano yung papunta pataas, ganun din pa baba. That is equal to 4.0 seconds. Ito pa, yung VI mo, let's say yung VI dito ay 5. Siyempre, because of gravity, mag-decrease ng mag-decrease, pag na-reach niya yung peak, hanggang magiging 0 meter per second. So, that is your VF. VI is 5. VF becomes 0 at the top. The time taken is 4.0 seconds. Ngayon, mag-start yan na bumaba because of gravity also. So, mag-gain ng velocity, mag-accelerate pababa. Its initial velocity from the top will become 0 meter per second. As it reaches the surface where it came from, that will be the final velocity, parehas dito sa initial velocity kanina. So, dapat 5 yan. Punta tayo sa problem. Okay, so with what velocity was the ball thrown? Our given is time, this is t sub t, t total, 8.0 seconds. And of course, g, that's negative 9.8 meters per second squared. Unknown is vi, hanggang sa peak. From this point up to the peak. Okay, so we can use VF is equal to VI plus GT. And we want to find out VI. Okay? So, transpose VF minus GT is equal to VI. This one will be our formula. VI is equal to, what is VF? Ano yung VF natin?
0
Zero.
meters.
Bakit 0 meter per
0,
second?
sir.
Kasi dun siya nag-stop.
Kasi, nung tumaas yung bola, na-reach niya yung peak, magiging 0 meter per second. Saka, babalik. So, its final velocity will be 0 meter per second minus negative 9.8 meters per second squared times time is, anong time ang gagamitin natin?
4 seconds.
Bakit 4 seconds?
Because that is the half of a...
Kasi bumalik, sir.
That's the time taken by the ball to reach the peak to have a velocity of 0 meter per second. So 4.0 seconds. So VI is equal to, ayan, negative times negative, positive, 9.8 times 4, 39.2. Counter check. 39.2 meters per second. We have 39 meters per second. Hindi 40 kasi 2 ito. Ayan. 39 meters per second.
Sir,
Yes.
yung VF po doon, sir, di ba po dapat VI po yun?
Sorry. Yeah. VI. Our VI is 39 meters per second. So our VI here is 39 meters per second. Positive. Bakit positive? Going upwards, not only that, nasa taas siya, pataas from the point of origin. Second question natin, supposedly dito sa page na to, how high did the ball go? So anong equation ang pwede nating gamitin diyan?
VIT plus 1 half G 1 plus 1 half times G times T squared.
VIT. Ayan. So, yun yung formula for displacement. So, ang tinatanong dito, gaano kataas yung naabot nung bola. Ang concern mo lang ay yung from the point of origin upwards. Your height there can be computed by looking for displacement. Use the formula D is equal to VI T plus 1 half GT squared. So D is equal to VI of 39 meters per second times T is 4.0 seconds plus 1 half negative 9.8 meters per second squared times T squared is 4.0 squared. What's the answer?
312 plus 312 meter plus negative 313.6.
312 meters plus negative
313.6, sir.
313.6 meters. Anong sagot?
Ay, wait lang, sir. Wait lang, sir. Negative 78.4 lang pala yan, sir.
Negative 78.4. Counter check nyo.
Lumaki masyado.
Tama ba?
Opo, sir, negative 78.4.
Negative 78.4 or 78 meters. So 312 plus negative 78,
234, sir.
we have 234 meters.
Yung 312 meters, sir, kuan, 39 times 4, 156, sir.
Yes, sir.
Oo nga pala, sir. 39 point times 1.
Wala po siyang square, sir, dapat.
Ala
Or hindi siya
ka.
na times 2 dapat. Times 2 po ata.
Sige, okay
Kaya-
lang. Yeah, sige. Yan. O, tama to. Para ano? Para hindi lang ako nagsasalita, di ba? Ayan. So, 39 times 4 is
156, sir.
156 meters. So, 156 minus 78,
78 din lang, sir.
that is equal to
78.
78 meters.
78 meters. So, your height, therefore, height is equal to 78 meters.